Hello and welcome to problem solving session on refraction of light. Today we'll walk through 6 problems to clear most of the concept in refraction. So here's our first problem. A ray of light travels in 3 mediums A, B and C with refractive indices N1, N2 and N3 respective. So here are the 3 mediums A, N1, B with refractive index N2 and N3 with C with refractive index N3. Now based on the ray diagram below, the correct order of refractive index is what we need to determine. There are no numerical value provided. So all the hint is basically into this diagram. So as we recall from our video on Snell's law, that if a ray of light is traveling like this from medium 1 to medium 2, it will pass unreflected like that, but it gets reflected towards the normal, right? If this angle becomes smaller, basically N2 is greater than N1. It bends away from the normal, right? Then basically N1 is greater than N2. Okay, so this is a lighter medium in that case. So with that, let's get started and try to find if we can find a relationship like that here. First thing first, in all the refraction problem, let's draw our normal and see how the ray of light is going. So if it was unreflected, it will go like this, but it's bending away. It's bending away, right? Which means that N2 is less than N1. Now here it is again bending further away, right? Which means that N3 is also less than N2. And if we can look at this angle, right, we can see that it's bending further away here, which means that N3 is the smallest, and then we have N2, and then we have this angle which is smaller than this, is basically N1. So this one, sorry, N3 is the smallest. Okay, so N1, N2, N3. So that should be our answer. Now let's move to the next problem. Quite similar, a ray of light travels through medium A, B and C, then back to A with refractive index given N1, N2, N3 and N4, and the ray of light is traveling like this. And again we need to find out the relationship between the refractive indices. Applying the same concept, first thing first, we'll draw our normal here at all the points. Now we can see that size of this theta, this angle, and this angle, right? Now with this here, we can clearly see that this is the smallest one, right? Which means it is the densest. So N4 is the densest. This followed by this angle, right? It is bigger than N1 and N3. So N2. And now this one. And finally, the smallest one is gone, the biggest one, which is N3, right? So this is the lightest medium, hence ray of light is bending more and more like that. So that should be our answer. So we can see N4, okay, N2, N1 and N3, and here the B is the correct answer. Now a parallel ray of light is incident on a strip of material ABCD. The refractive indices shown in the figure below. There is a possibility that the ray of light will get trapped in one of the material layers, so that it will emerge through strip towards the right side. Most likely that layer is, which means that in some of the layer the total internal reflection will happen. After several reflection, the ray of light will come from this side, right? We know that if we have a ray of light coming like this, and if we have a total internal reflection, you know, it can just travel through the pipe and basically comes out from this side, right? We need to determine in which layer the total internal reflection will happen. So we know that the total internal reflection condition is very simple, that this medium has to be a lighter medium, which means N has to be less, and this has to be a denser medium, say medium 1, medium 2, and n1 has to be greater than n2, right? So let's see where it meets. So herein it is going from sort of lighter medium to the denser medium, so no total internal reflection can happen over here. Here again from the lighter to a denser, so no total internal reflection can happen in C. In here 1.5 to 1.3, so yes, a total internal reflection can happen over here. And here a denser medium to a lighter medium, so yeah, and then again from 1.3 to air, a denser medium to a lighter medium. So now we also know that for the total internal reflection, at least the n value has to be under root 2 or n has to be greater than 1.414, right? So that is the second condition for the total internal reflection in pipes, which you remember that formula. So hence the only condition which satisfies this is the B, and hence B is the correct answer. Now we have three blocks 1, 2, 3. So 1, 2, 3 with refractive indices n1, n2 and n3, which are able to totally internally reflect the ray of light coming from point A from the darker region to the left. The correct order of refractive index is given by, right? So now it is saying that, okay, here it is n1, and then you have air, and the ray of light is getting totally internally reflected into this, right, in all the three. But as we change this critical angle, right, in this medium, when the value of refractiveness is n1, we have a bigger critical angle. Okay, we have bigger critical angle. Here we have less, and here we have very less, right? So let's write a general formula for finding the critical angle. So here we have theta, and like that, and let's say n. So n sine theta is going to be, this is 90 in the air into sine 90, it's going to be 1, and sine of theta is going to be 1 by n. And as we know, the value of sine theta increases from 0 to 90 degrees, right, from 0 to 1. So for this theta to be bigger, right, it has to be greater than that, right? For the theta to be bigger, the n has to be smaller, okay, which means that wherever we have this bigger theta, the n1 is the smallest one, and then followed by n2, and then followed by n3, and if we can find that here, yes, in here, and that is our answer. Moving on to the next problem. Now this looks heavy, but let's see. So a student performs an experiment on refraction of light and plots the dependence of angle of incidence and angle of refraction between the medium and a water. So water, and there's a refraction happening here, and student is doing some experiment. So he performs the experiment for two such mediums, 1 and 2, and makes the graph shown below. Okay, this is the graph. Choose the correct option. So let's see first what it is before we move on to the answer thing. So now let's look at this graph, right? So here is our angle of incidence, and here is angle of refraction. In a general case, basically we are looking at, let's say here, so this is our angle of incidence, and this is our angle of refraction, right? And we need to figure out if this medium is denser or this one is denser, right? So the question says that refractive index of both the medium 1, 2 is greater than 4 by 3 or not. So water is given to be 4 by 3, right? So with that in mind, let's start. So angle of incidence here is that, and so now for any of the angle incidence and angle of refraction, if they were same, right, we'll get a straight line here, right? It will meet here, sorry. For any medium where the angle of incidence and angle of refraction will be same, it will be a straight line, and we can see these two graphs are basically above that. What it means is that when we have angle of incidence here, right, at 45 degrees, it is more than 45 degrees. So angle of refraction is basically more than the angle of incidence, which means that something like that is happening, right? So this is angle of incidence and this is angle of refraction, right? Which means that basically this medium, right? So refractive index of the medium is greater than 4 by 3 in both the cases, because this graph basically lies above this line, right? So refractive index of both the medium 1 is greater than 4 by 3, which is a water, and medium 2 is also greater than 4 by 3, and it is quite easy to see from the position of this chart. So first one, refractive index of both medium 1 and 2 is greater than 4 by 3 is correct. The refractive index of medium 1 is greater than 4 by 3, while that of material 2 is less than is incorrect. Now refractive index of medium 1 is 1.9 and so on. So now we need to calculate the refractive index of medium 1. So how do we do that? It's quite easy. If we just look at the angle of incidence here, right, which is 45 degrees, right? The angle of refraction here becomes 90 degrees, right? Now we can simply write that our equation for the medium 1. So n1 sine 45, right? This is the angle of incidence. So this is our angle of incidence, and then the angle of refraction becomes 90, right? Which is water 4 by 3 into sine 90, which is 1. So you will find that n1 is finally going to be 1.9. Okay. Similarly, for the medium 2, we can see that the angle of incidence now is 60 degrees, right? So we can write n1 sine 60, sorry, this is medium 2, n2 sine 60 is equal to 4 by 3, and this one is also sine 60. So dividing that, basically we have n2 is equal to 1.4, and hence n1 is 1.9 and n2 is 1.4, and this is the correct answer, this is the wrong answer. Okay. Now the next question, we have three materials with refractive index n1, n2 and n3, and they are arranged in layers of uniform thickness. The ray of light in air enters the first layer at an angle of incidence 30 degree, and the ray eventually exits the third layer at a refractive angle q in the air. What is the value of q, right? So let's simply draw this. We have 1, 2, 3. We have this air here, this air here, and this is n1, n2 and n3. Our ray of light is entering here at an angle 30. Some refraction is happening, and finally when it leaves at an angle q, and we want to know what is q, right? That's pretty simple, because as we said in our Snell's law lecture, that basically, for all this refraction happening, and into sine theta, right, is always a constant, right? It does not matter how many refraction is got in between. If it is coming out in the air, right, so here if we write, so n1 is basically 1 into sine 30, right? We can write the second part of the equation directly here, which is going to be again 1 into sine q, and for this to be equal, basically the q has to be 30 degrees, right? We do not worry about what happens in between. We can always write half the equation for the Snell's law, which is n1 sine theta 1 is equal to n2 sine theta 2, so on and so forth, is constant. So half, right, we can write here, and half we can write here, and we are done with that, right? So similarly, we have done that 1 sine theta is equal to 1 into sine q, and with that we know the q is 30. So here is our answer. Okay, so these were the short problems we covered today, and we learned few things that, just by looking at the ray diagram, we can find relationship or relationship between the refractive index of different mediums. Okay, and we can apply Snell's law, sine theta and sine theta is constant, right? Without worrying about what happens in between. So one part on this, half part from on this point and another part from this point, and it will always be correct, right? So with that, we'll close this video, and if you have question, you can post. We have more videos like this coming up, and we have a full course. Most of them is free. You can go deep dive physics. Sign up and can get access to all the videos, and we are also providing online tutoring. If you're interested, please get in touch for more details. Thank you very much.